Okay, so welcome to this lightning talk about a journey in geospatial time series. With Postgres, I am Nils Larsgård. I work at Kodemaker as a full stack developer, and I love this tool called Postgres. So geospatial what now? Geospatial time series is just a regular time series. Time series is a data point observed in time. So geospatial time series is time, location, and some metadata. That's the fancy word. Okay, so the use case for this talk is that I am creating a mobile application with Norwegian data. This screenshot, as you see, is from the application. And I want to stream some AIS data from the Norwegian Coastal Administration using the maps from the Norwegian Mapping Authority to present this. So when I do this, I want to store relevant events about the ships. So I forgot to mention, the app is about marine traffic on the Norwegian coast. And I want to store as much positioning data from the ships as I can possibly do. So the architecture is real simple. The coastal services is providing me data. I have a backend which is ingesting this data, storing it to a database, and presenting it nicely to an application. So first things first. AIS, what is this? Automatic Identification System. It's a protocol, a binary protocol, that's used worldwide for marine traffic. Ships all over the world has antennas on their ships, broadcasting over radio these binary messages. And there are antennas on the shore and antennas on satellites that are receiving these messages and storing them into servers. So the coastal services are gathering this and broadcasting them further to me over a TCP stream. So these messages, they contain quite a lot of information. It's 27 different types, and they contain all relevant information that I need about ships. And this is unknown to me. I don't know really what AIS is about, so I know how to Google, but this is an unknown domain to me. The thing that I see in all packages is that they have some user ID. User ID is the identification of the ship. So, going to Postgres, I can do this without knowing too much about AIS, because I don't know. Since I don't know AIS, I don't want to upfront design my database table. So I just use the JSONB type in Postgres to start. So when I insert data here, I just use a regular JSON string, insert it into this ship info table. And later on, when I find out that there's more information from these packages that I should store, for instance, this IMO number, I can use functions from Postgres to manipulate the JSON payload. So to manipulate the JSON payload or to extract stuff from the JSON payload, I use this built-in JSONB functions. So this payload, for instance, if I want to extract the name and the dimension, I have to use some kind of convoluted SQL to do this, but it's regular SQL with some Postgres syntax to it. So extracting the name, I have to use this arrow syntax or double arrow, and criteria selection. The selection criteria, I have to use this hashtags or some other functions provided by Postgres. So you see now that the SQL is getting a bit difficult, but at least I run it in a database with SQL. And I get to do whatever I can store the data I want to in Postgres. And I can even add indexes on the nested fields in the JSON structure if I want to. Beware that the query planner will probably not be as efficient when you do this as if you are designing a regular SQL table. Okay, so now I've stored my data. And tackling the positioning is quite easy, right? Because I know where I am at This position is just 2 coordinates, longitude and latitude. That's easy. Store it in a database, done with it. But if you want to do complex stuff here, you quickly find out that the projection is hard. Positioning is easy, projection is hard. Because I'm used to thinking in this Cartesian coordinate system on the left. Calculating the distance between the red and the green dot is easy in the Cartesian coordinate system. But in the real world, when you're dealing with maps, you deal with ellipsoidal coordinate systems. And then you have to consider the curvature of the Earth, and the distances on the top of the map is not the same as the distance on the bottom of the map, because it's flattened out, right? So to actually calculate distances, you probably have to have a PhD in mathematics or something. But lucky me, there's an extension for that. It's called PostGIS. It's an open source extension for Postgres, and this lets me do what I want to do with these geographical types. It's a permissive license, you can run it anywhere. And it lets me store, query, and index geographical data types, not just points or lines, but like polygons and areas and envelopes and stuff like that. So going back to the application, I can now ask PostGIS what ships are inside this polygon of the app view, and it will return the IDs of the ship. I can even ask it to calculate what's the distance between all these points for last hour, 3 hours, or 3 weeks, no, 2 weeks even. Or just give me the distance to the closest boats. So using this, I have now a new type in my database. It's called geography points. And I'm using a coordinate system 4326. 4326 is just one of the 1,000 standards you can choose from. So my strategy is just pick one and stick with it. So I choose you as our ID 4326. This is not the standard that Google Maps is using, but it's the same standard that Kartverket or the mapping services are using in Norway. So that's a good coincidence. So inserting data, it's straightforward. Specify what coordinate system you're using and a point, and you're done with it. Querying data is, again, a bit convoluted because you have to use these weird functions from PostGIS, but you get to do what you want. And just reading this code, you understand, or it's not that hard to understand that I'm querying for user IDs and positioning for all the ships inside this envelope. Just return it to me. And PostGIS will do so. OK. So now I've stored data, I've stored positions in Postgres. But there's a problem with data, right? And you all know that. It's just too much of it. These boats, they don't stop moving. They produce positioning data all the time. And my disk is getting full, my index is getting heavy, inserts takes longer and longer time, and querying the data is also taking longer and longer time. But lucky me, there's an extension for that. It's called Timescale. So Timescale is an open source extension as well. It's not that permissive license as PostGIS, but if you want to run it on your own premises, that's fine. If you're a cloud provider, not fine. But this optimizes the storage and queries on timeseries. And it promised me that it will do automatic aggregation, automatic retention, and it has some really nice statistical functions for your aggregates. So going back to the table with the geography type, I now add a line here that I'm telling Timescale to create a hypertable of the trail table. And I tell them, OK, you should chunk the data here within one day interval. What Timescale would do is taking the normal table and chunk it to kind of chunks, as it's called. I'm looking at it as some partitions. And this makes inserting and querying data a lot quicker. I don't have to deal with chunks. I just use regular SQL for it. So I'm creating materialized views as normal, almost. As you can see in the second line, I'm telling Timescale that this is a continuous aggregate. this aggregate should be updated all the time. And I'm telling it, not all the time, I'm telling it also when to update it and what time window it should aggregate on. So now I have this aggregation on the trail table. And the thing about time series is that the freshest data is the most valuable. The older the data gets, it's less valuable. So I can just keep the aggregate and discard the rest. So after 7 days, just drop the data, and I'm fine with it. So now I can tell my user that if you want to see the trail for this boat for 1 hour or the 24 last hours, so 2 weeks or even 2 months, you can do that. I have the data aggregated. So to sum it up, I get flexibility with JSONB from Postgres. I use PostGIS for geospatial data and Timescale for time series. And all this within just Postgres, no specialized database. Thank you.